Boolean algebra is used to combine different set algebra or other selection type criteria in order to make more complicated selections. With Boolean algebra, we're talking about the operators and, or, and not. So let's look at some examples here. Here would be one expression here: area is greater than 100,000 and the farm income is less than 10 billion. Both of those expressions, both of those set algebra expressions, area greater than 100,000 and also farm income less than 10 billion, would both have to be true in order for an individual feature to be selected here. Another way we can use Boolean algebra is to select something like state equals Texas, and then not would select everything that was not the state equal to Texas. This would be pretty similar to the set algebra thing that we could do not equal to. Here's a more complicated one here. So in this case, we're looking for areas where rainfall is greater than 1,000 and taxes are low. So both of those would have to be true for some of those to be selected. But then there's a whole nother subset that could also be selected, and this or means that only one of them has to be true in order for one to be selected. So the other thing that could be true is house cost is less than 6,500 and not crime equals high, or the crime is equal to low there. So once again, both of these would have to be true for them to be selected, but then all the ones selected with this part of the expression, in addition to all the ones selected with this part of the expression, would be selected, because the or indicates only one of those has to be true in order for the selection to take place. So we can think of these like Venn diagrams. If we have these three different regions here, A, B, and C, if we want to select A or B, it's everything in A in addition to everything in A and A here in addition to everything in B here. But if we say A and B, then the only area that has both of those in common and would be selected would be the area of overlap here, where A overlaps B. If we said not A or B, we would start with A or B and then select what was not selected, unselect this and select what was not selected, and end up with this part of C here. And not A and B, we start with A and B, and then we take everything that's not that by looking at everything outside of here. And then finally, we could sometimes add parentheses so we know what to do first. So in this case, we've selected A and B, which of course would be this. And then in addition to that, we've said or C, which would be everything in C, everything in this value C here, so that we get this resulting shape here. So the and operator tends to select smaller areas, and the or operator includes larger areas because it only has to be in one or the other in order for it to be included in the selected set. Here's an example here where we have two different things on this map. One are the county lines, and the other is this entire darker orange area here, and really dark orange area, which is the Cannon River watershed. So if we wanted to select just the area in darkest orange here, that brownish orange color, we would say the county has to be Rice County and the watershed has to equal Cannon. So both of those criteria have to be true. So we're not selecting parts of Rice County that are not in the watershed, and we're not selecting part of the watersheds that are not in Rice County. So once again, in this case, limits our selection. Both of those things have to be true in order for the area to be selected.